Hi everyone, this video is about set theory. So what is set theory? Set theory is a true study of infinity. When we say infinity, it's countless, it's uncountable. This alone measures the subset of a place prominent in human culture, which is the application of this set theory. But even more, set theory is the milieu in which mathematics takes place today. As such, it is expected to provide a firm foundation for the rest of the mathematics. So, we're going to define the word set for us to understand clearly and vividly the set theory. So, what is the word set? Set is a collection of a distinct object. When we say distinct objects, it has no any repetition. And anyway, to write the set, it is in boldface and it is in capital letter, like this one. So we have set A, and of course, set has an element or has a member. Okay, it is written in equal sign and then enclose the elements or the member inside the open and close parentheses. So we're going to read it as a set A has a member of X, Y, and Z. An empty set. The empty set or null set is the set having no any element. So what if we do not have any members inside a set? Is that possible? The answer is yes. We're going to write this like this one. Do not include anything inside the open and close parentheses, or we can have this one. That is an empty set. Next that we have here is the cardinality. The cardinality or cardinal number of a set is the number of elements in a set. So I'm going to give you an example for you to understand it better. So we have set A, and it has an element of 1, 2, 3, 4, 7, 6, and 5. So we're going to count how many elements inside a set. We have a 1, 2, 3, 4, 5, 6, 7. So therefore, we have 7 elements inside a set A. How are we going to write this? Like this one. We're going to use like an absolute value symbol, enclose it or put the letter A inside of it, and then equal to the number, which is the number of the element. So again, set A has a member of 1, 2, 3, 4, 7, 6, 5. Therefore, the cardinality of set A is equal to 7. We have 3 ways to define or identify a set. Rather, the first one is that, so before we have reading description, list method, and set builder notation. We have here an example, January, June, and July. So we're going to apply it. Okay, so how are you going to answer the given January, June, and July and identify it using a written description? The answer is this one. A is the set of calendar months beginning with the letter J. So that's correct. January, June, and July starts with the letter J. Next is the list method. A is an element of June, July, January, which is still correct. In list method, we're going to use it as we had earlier. We used it, right? We used the set A equal sign and open and close parentheses. Next one is the set builder notation. January, June, and July can be defined as set A is a set of element X, such as X is a calendar month beginning with the letter J. So for you to understand it better, I'm going to give you another example. We have here a primary colors, a wheel of primary colors. Using a written description, it could be answered as B is the set of primary colors. In list method, it will be answered as B is equal, or rather B has an element of red, blue, and yellow. And in set builder notation, it could be answered as B has a set of element of X, such as X is a primary color. Next, that we are going to discuss the basic concepts of a set theory. We actually have three: the abstraction, extension, and inclusion. Let's start first with the abstraction. So how are we going to define the abstraction? It means each property defines a set, and each set defines a property. In this case, we have the subject and the predicate. Of course, the predicate will describe or define the subject. For example, we have here set A has an element of X, such as P of X. Therefore, we can also say that X is inside the set A, which has an element of P of X, like that we have here. So, this one is a predicate which defines the subject. Therefore, the set of all objects such as X, such that P of X is like equal to this given. So again, we're going to the set X of a X as an element of A is equal to P of X. Next one is that we have the extension. Extension means both sets have the same element if and only if they contain the same element. This concept has two important consequences. First, the element of a set are equal. And the second, there is an ordering of the element of a set. For example, set A has an element of A and B, and set B has an element of B and A. Therefore, they are the same because they contain the same element. The difference is just that the set A has an element of A and B, and set B has an element of B and A. The letter A comes first in the set A, while the elements or member B comes first in the set B. But still, they are equal. So we could say that A is equal to B. That is, they have the same element, therefore they are equal. Next one is that we have the inclusion. So I have here an example. Set A has an element of 1, 2, 3, 4, 5, 6, 7, and set B has an element of 1, 2, 3. A set B is a subset of a set A, or equivalently, A is a superset of B. If B contained inside A, that is, all elements of B are also elements of A, correct? Yes. A and B may coincide. The relationship of one set being a subset of another is called inclusion, or sometimes containment. This is our A and this is B. That's why we call it a set B is a subset of set A, or set A is a superset of B. That's the first part of the set theory. If you have any question, feel free to post a comment. Please do like it if you like it, and I hope you learned something from this. Thank you for listening. This is Romeline Velasco of SDI. Thank you, everyone.